Hello, today we are covering 2.5 Scatterplots and 2.4 extension piecewise functions. So you guys will be able to write linear equations that model data and make predictions from linear models. So first of all, we have 5 little graphs here explaining different types of correlations. So a strong negative correlation is when all the points are close together and they form a sort of negative slope. A weak negative correlation is when you can still see a sort of correlation, but they're not quite as closely packed, but they're still slightly negative. No correlation is when the points are spread throughout the graph. They don't make any sort of looking like a line. A weak positive correlation is when the points are spread apart but still make a positive sort of slope, and a strong positive correlation is when the points are definitely close together and they make a positive slope. So we have an example here. The table below shows the number of hours students spent online the day before a test and the scores of the test. Make a scatter plot. How would you describe the correlation? So we are going to first start by labeling our x and y axes and then plotting our points. So I'm going to label my x-axis the number of hours online, and then label them 0, 1, 2, 3, 4, 5, and 6 hours. And then the y-axis is the test score. So I'm going to label these. Oh, I forgot. Got to label the y-axis too. I'm going to count by 10 so I can make it all the way to 100. Now I'll plot my points. So we have 0, 100. We have 0, 94. 198, 188, 188, 1.592, 1.75, 89, 2 is 75, 2 is 70, 3 is 78, 4 is 72, 4.5 is 57, and 5 is 60. So this looks like a strong negative correlation. We can see there's kind of a negative slope here, and they're pretty well grouped together. So we now can take something called a trend line. A trend line is a line that approximates the relationships between the variables or data sets of a scatter plot. You can use a trend line to make predictions from the data. So what I'm going to do now is I'm going to choose 2 points that looked pretty well centered within my data set. I'm going to choose 190, and I'm going to choose 280. We are going to draw in that trend line from the graph above. So through those 2 points, we're going to write an equation of the trend line and also use the trend line to predict what test score we would have if we spent 6 hours online the day before the test. So I need to find my slope. If I'd like, I can just look at the graph. I know I will rise 10 because this axis is counting by tenths, and I will run -1. So that means my slope there is -10. If that's a little confusing to you, you can go ahead and do y2 minus y1 equals x2 minus x1 and you end up getting -10. Either way. Now, since we are going to write the equation of the trend line in slope-intercept form, we can go ahead and plug in either one of these plus our slope. So I'm going to have 90 equals -10 times 1 plus b, and solve for b. So b will equal 100, and I can plug this in. Y equals -10x plus 100. Now recall, this is just a guess. It's an approximation. So if you spent 6 hours online the day before the test, that is our x value here. So let's plug 6 into our equation, our trend line. So we have y equals -10 times 6 plus 100. So if we solve for your possible score, we would get that it's likely you will get a 40% on that test if you spend 6 hours online the day before. So approximating our trend line is pretty awesome, but we should know how to get the actual line of best fit. We will use a graphing calculator, and you'll need to know this for your Math Excel homework, to find a linear regression line. So if you don't have a graphing calculator at home, you can follow how I get to one on our iPad. So we have an app that looks like this. It is iStep Practice. It's a little gray calculator. Click on that. It'll bring up a bunch of states. If you click on Maryland and then click Practice Tests, you can go down to the mathematics tutorials and do the high school computer-based assessment tutorial. You'll hit start again, and start one more time. And then up in the very top, you have a graphing calculator you can load. Okay? So now, you're going to hit the Stat button. Then you will hit Edit, just enter, and you will enter in the L1 column all your x values. So I'm going to say 0, enter, 0, enter, 1, enter, 1, enter, 1.5, and so on and so forth. Fill out all of these. And 5. Okay, now come up to your other column, I guess arrow over, and fill in all your y values. So we have 100, 94, 98, 88, 92, 89, 75, 70, 78, 72, 57, and 60. And they should line up the same number in each column. Once you got that done, you'll go to Stat. You'll arrow over to Calc and go to Linear Reg or Linear Regression, AX plus B, and hit Enter. You'll arrow down to Calculate and hit Enter there. And then you are given the values for your actual regression line. So I will pull that up, and if we want our actual regression line, this is y equals -7.91x plus 98.05. So this is actual. And our first one is estimate. Alrighty, 2.4 piecewise functions. You guys will be able to graph these functions by the end of this lesson. So to evaluate for f of x, or you can think of this as y if you want, when for a part A, x equals 0, part B, x equals 2, and part C, x equals 4. Now you're not going to plug these numbers into both of these equations here. You first look at your inequalities. So if the value for x is less than 2, which it is here, you are going to plug into this equation. If the value for x is greater than or equal to 2, as it will be for B and C, you will plug these both into the second equation, okay? So, for the first one, because 0 is less than 2, you will plug f of x, x plus 2. You'll plug in f of 0. For x will be 0, and you will get that our solution is 2. For the next two, x equals 2 and x equals 4, we will use the second equation. So we'll use f of x equals 2x plus 1. We'll plug in f of 2 because that satisfies our stipulation here. And we will solve and get that f of 2 equals 5. We'll also use that same equation for the next one. Actually, let's use a different color. We'll use f of x equals 2x plus 1 because 4 is definitely bigger than 2. So f of 4 will equal 2 times 4 plus 1, or 9. Okay? So for those, you just have to pick which equation to plug your x value into based on your inequalities attached. The next examples, the rest of them in this lesson, are graphing. And piecewise functions means that we will have 2 or more pieces to our picture. Okay? So, first, look at your inequalities. In this case, x's are either less than 2 or greater than and equal to 2. So I'm going to draw a line at x equals 2. We'll get rid of that line at the end. But for now, I'm going to have this here. Everything on the left side of this line are x's less than 2. And everything on the right side of this line are x's greater than or equal to 2. So if you notice, on the left side of the equation, we will graph this line, and on the right side, we will graph this line. So the line f of x equals to x plus 2. I'm going to start by graphing my y-intercept of 2. And then my slope here is actually 1 over 1. So I'm going to rise 1, run 1, rise 1, run 1 to that line. And then I can go the other way as well because I know this line cannot extend past this because all my x's need to be smaller than 2. Okay? Now there's one other tricky thing. Because this is a less than symbol here, that one on that line must be an open circle. 2 is not included in the solutions for that piece of our function. Okay, so that's the first one. Our second one then, we are going to start with the y-intercept of 1. Now we are going to have to plot things on the wrong side of the x line, the x equals 2 line for now. So that way we know we have it in the right spot. And my slope is 2 over 1, so I'm going to rise 2, run 1, rise 2, run 1. Notice that's where it'll start on this line. Rise 2, run 1, rise 2, run 1. So I know because this piece is going to be x's greater than or equal to 2, I'm only going to graph what's on that side of my x equals 2 line. and I can get rid of the rest of the dots. Okay? Now this one is a closed circle because it is a greater than or equal to. All right. So now I can get rid of this line here, and that is the graph of my piecewise function. Math Excel will ask you for your domain and range. So our domain on this one, domain is our x values. How far will these graphs go from left to right? Eventually these graphs will hit infinity. So we could say all real numbers. We could use the shortened form with a fancy R, or you can say from negative infinity to positive infinity. Okay? For our range is a little different. This is our y value, so how far the graph extends up and down. It's almost all real numbers, but we have this little space here that is not included, so we can't just say all real numbers. So we can say that our range is y values strictly less than 4, if you see. Here's 4, our y values go less than 4, comma, y values greater than or equal to 5, because we start at 5 and we can go up. And that would be our range. Okay? That's the only one we'll look at, domain and range, but Math Excel will have you look at those. This guy, first look at where we will have our pieces split off. We will have an imaginary line here, but drawn in for now at x equals 1. Our first line, 1/2 x plus 5. Our x is less than 1, so you know this guy will be an open circle. And our second line is x is greater than or equal to 1, so we know this is a closed circle. So I'm going to plot the first one. I'm going to start at positive 5. Then I'm going to fall 1, run 2. It must be a positive slope, but I don't want to go on the other side of the blue line, so I'm graphing this way. So that is my 1/2 x plus 5. I'll have an open circle on that x equals 1 line. And that is my first piece graphed. My second piece, we start at positive 3. Yes, I do have to put it on the wrong side of the line briefly. And then I have a slope of negative 1 over 1. So I fall 1, run 1, fall 1, run 1, fall 1, run 1. That's a negative slope. I do have a closed circle on my x equals 1 line, so I can graph it down. I'm going to go ahead and erase that and erase my x equals 1 line. And that is the graph of my piecewise function. And lastly, once again, look at the values of your inequalities. That's where you'll put an imaginary line for now. Then you'll go ahead and graph these guys. So we have x is greater than 2, and we have x is less than or equal to 2. So this guy is going to be on the left side, and this guy will be on the right side. I'll graph that first one. Once again, he's going to have to be briefly on the wrong side of our x equals 2 line. Graph up 4. Then I rise 2, run 3, rise 2, run 3, rise 2, run 3. This guy will be an open circle, we see by this. So draw my line, extend it down, that'll be an open circle here. Get rid of this other purple dot because he's on the wrong side of the line. Then I will draw my other line on the right side here. The y-intercept is 1, the slope is -1. So I have a negative slope, come down, make sure it's the slant of an N. It is a closed circle on the x equals 2 line. Go ahead and draw in the graph. And I can get rid of that imaginary line, and I have my 2 pieces of my piecewise function graphed. Alrighty, have a great afternoon.